In 1908, German mathematician Hermann Minkowski created the concept of physics known as space-time. Space-time combines the three dimensions of space and the one dimension of time into a four-dimensional space-time continuum. To truly understand this concept, we have to first travel back to Newton's time. Isaac Newton was a revolutionary scientist in the 17th century and is regarded as one of the most influential scientists of all time. Newton contributes to space-time for his work on both relative velocity and gravity. Newton explains that velocity is relative, which can be understood by thinking of a moving car. If a car is going 60 miles per hour, to a non-moving spectator that car will appear to be traveling at that speed, 60 miles per hour. However, if the spectator is also traveling in a car, but the car is moving 20 miles per hour, the first car will appear to be traveling at 40 miles per hour. Furthermore, if the spectator was moving in the opposite direction of the first car would appear to be traveling at 80 miles per hour. Newton concluded that this property is true not only on Earth, but in the entire galaxy. Albert Einstein used this idea to explain one of his famous scenarios. Imagine a man riding the train and he passes a clock tower. As he watches the clock tower from a train moving 40 miles per hour, time would move as you expect. However, he hypothesized that if the train were moving at the speed of light, the clock's minute hand would in fact appear to stop. Thus, he noted that time effectively had slowed down at the speed of light. He concluded that the faster you move through space, the slower you move through time. Of course, this concept is revolutionary because it challenges the Newtonian idea that time moves in a constant forward direction. Minkowski noted that because time is dependent on velocity, it must be given its own dimension, hence the space-time continuum. In 2004, a probe was sent to observe the fabric of space-time. 7 years later, NASA researchers concluded that Einstein's concept of the space-time fabric does indeed exist, and its shape mirrors Einstein's prediction. Space-time is still not completely understood, but the theory opens the doors to a world of discovery in modern physics and space scientists who strive to understand the relationship between space and time. Famous poet Edgar Allan Poe concluded that space and duration are one in an essay titled Eureka. I anticipate new discoveries regarding space-time and other phenomena in our atmosphere.